Hello and welcome to another video. You've seen me use this dummy load in the past. This is essentially a device where you can set the current, for example 1 amp, and it's going to pull 1 amp whatsoever, so this is used for testing power supplies. This I built on my own quite some time ago. It's fairly nice, I really like it, but maybe half a year ago I saw on Kickstarter some guy called Nick Johnson, I think, from Arachnid Labs put up a Kickstarter campaign for this Reload Pro. And in case you're not aware of that, Arachnid Labs, they have quite a number of fairly cool projects. I believe all of them are open source, and I wanted to support this guy. So even though I wasn't really in the need for a new dummy load, I backed this campaign. And also, of course, I was a little bit intrigued by the nice features here, because this has a USB port, so you can hook up a computer, and it's very easy to script different kinds of load patterns and do some a readout of the measurements and whatever. So in this video I'm going to review this unit. It's brand new, it arrived 2 days ago, and we're going to have a look at how it works. To summarize, I really would recommend this unit, and I would buy it again if I was looking for a device with this set of features at this price. Now, we're going to look at all of that. I think that the software really needs some improvement, although he's working on that right now, and in the last few days there have been multiple firmware upgrades or updates actually. So I think this is really on the way to getting a success. Okay, so oh, and one more thing, I don't really like to do reviews because it also involves like saying what's bad, and I try to be a nice guy, so just keep that in mind. I like this unit and I would buy it again. And also, you know, you can always be super harsh. If I were to review my own unit here, I would, for example, say that there is no on-off button. I mean, that sucks, because very often you want to set up everything and then connect the load by pressing one button, and I don't have that. Also, this knob here is really hard to, you know, to get to, because there is like this prongs in the way, and also it would have been a great idea to label which one is the input and which one is the readout, because otherwise you plug in your load into the readout and you break the unit, and so on. So there is always, you know, a lot of things to nitpick, and I'll try to do my best to highlight what I like and what I don't like, and essentially in the end it's up to you, but I think this is a nice unit anyway. So let's get rid of that and have a look at the unit. First of all, this is a really nice machined case. I think it's custom machined. There is the heatsink on the back here, really nice, a sticker that tells you that this is getting hot. Rubber feet, it's not rubber I think, but there's some sort of feet, which is really nice, because otherwise it would scratch my power supply here, so this is great. Then what more? Yeah, it comes with a manual, although to be honest the manual is not very helpful. For example, I would have been interested in what this is. If you follow the campaign, I believe at some point they were talking about adding some auxiliary input as an option, maybe for triggering or whatever, but the manual doesn't tell you what it is, and it makes sense, because it's a software option that is not programmed out yet, so it doesn't do anything, but it would have been nice for the manual to tell me that. And similarly, it would have been, the manual, for example, it tells you how to upgrade the firmware, although it doesn't tell you that you have to go into the menu and select upgrade firmware. You know, there is little things that make the manual a bit useless, because it's stating the obvious stuff, but the things that would have been helpful for me are somehow not in there. I'm not sure why he's providing a manual. Maybe it's because this is CE certified here. Maybe this requires a manual, and you know, the thing is that the firmware is changing at such a fast pace that the manual would be outdated anyway if there were more details. So anyway, there's that. What's missing from the manual is how to open it. You know, this is an open source device. It's supposed to be hackable and everything. And in fact, I found this to be, I'm not sure how to open it because, so first of all, you have to remove that knob here. If you look at that knob, there is no washer in here. So, or no nut actually. So it's moving around a little bit, and you're going to use this knob a lot. So it would have been nice to put a nut in there, and also this is an encoder here, and there is indents, but the space between the indents is fairly large. So you know, you're supposed to rotate it by one indent, and that's so much. But it's not. It feels weird because it's not quite clear what the state is in between. There is quite some slack here. But anyway, and another thing about this button here is that there is I believe this is a hex screw of some sort here that most likely you have to undo before you can open up the device, and that screw is quite small. I don't have any screwdriver of sorts to open that up, which is a bit annoying. But anyway, there is that. Also, the USB port is on the front, which is I don't really like that because it gets in the way. If I get the USB cable here, you've got that thing here, you know, being just in the way. And he's suggesting, and that is Nick Johnson is suggesting, to put a angular USB plug here that, you know, goes sideways. In my opinion, it would have been nicer to put it on the back, but actually there is a massive heatsink on the back. So it makes sense to me that he didn't do that because there's just no space for that. Anyway, there's that. Now let's power it up. In fact, let's plug this in here. This is connected to to this little device here, and this just shows how much current it is drawing, that's all. Okay, and the first thing I did when I got it is, of course, I plugged it in. So let's do that again. And that's what you get. Now, that's a bit disappointing because it's not powering on at all. And I was fairly confused. It's also almost drawing like no current at all. So I tried another computer here, like this, and then it powers up. So great, I'll get back to that issue. And you can see that this is drawing about 70 milliamps or thereabouts. Okay, now the manual tells you that the first thing you should do is you should calibrate the unit by going into the menu. Sorry for that. You go into the menu, and there is a lot of work in the software that has to be done. You go into calibrate, and it tells you to remove the leads. That's fine, so the leads are removed. And then the manual actually tells you that calibration works best when voltage of 9.9 volts is applied. So I'm going to do just that, 9.9 volts. And you're supposed to hook up a power supply that is able to deliver at least 2 amps, which is the case here. So now the power supply is set to 9.9 volts, and here I have to set the voltage, which is 9.9 volts. Of course, I have calibrated it already, which is why it's showing me the proper values already. So that's 9.9 volts, and then it actually pulls 2 amps. If you look at the power supply down here, it's pulling 2 amps here, more or less. It's a bit hard to read because there's a bit of oscillation there, but it's around about 2 amps. So I'm going to tell it that this is 2 amps here, and and hit next, and then it's going to calibrate. And it's actually doing interesting stuff here. It's pulling some current and then stopping and whatever. So it's calibrating. While it's doing that, let me tell you a bit more about the software, because I really think that there is a lot of work that has to be done there. For example, the buttons have to be debounced, and you know, like basic things like that. Also, I am not quite sure. I should have said that. So there is also a product called Reload, which is a very simple. It's essentially an operational amplifier and a MOSFET, and it's acting as dummy load in the ordinary sense. Now, what he did here is he took a system on a chip that has an op-amp built in, and he's using that op-amp together with the same MOSFET he's using for the normal reload to act as a dummy load. So of course, the dummy load, the performance of the op-amp is very important, you know, low offset, all these kinds of things. I'm not really sure whether he's using the current control or whether he's doing current control in the analog way, because I actually had the device open before and I hooked up my scope to the gate of the MOSFET, and it doesn't look like an analog control loop. But anyway, so I've got this unit calibrated now. So if I zoom in a bit more, so let's pull maybe half an amp, and also here, you know, it should. A software acceleration of the encoder is kind of important, because if I want to notch this up to 3 amps, I'm going to spend half a minute doing that at this pace. So, but this is easily solved in software, and I'm sure he's working on that. So I'm pulling 500 milliamps. The readback is almost 500 milliamps here. That's fine. And in fact, the power supply is saying that this is almost 500 milliamps, so no problems there. So this seems to be working. I played around with the voltage, and this all works within spec. However, if I turn this down to, let's say, 40 milliamps, it's kind of drawing 3 milliamps, and it's probably not drawing anything at all. Which is kind of weird. I'm not sure whether this is an open issue or whether this is by design. However, if you look at the specs, I believe that it should be able to do that, which is a bit of a shame, because in a way, at least for my applications, it's sort of important to be able to pull 50 milliamps, 40 milliamps currents like that. In theory, there is no reason why this unit shouldn't be able to do that. So anyway, there is that. Looking at the menu, there is not much more, unfortunately. The manual tells you that you should upgrade the firmware because there is, you know, lots of changes, which is true. He's really addressing all of these issues right now, which is also why I think this is really a unit you should consider for buying if you need one. But right now this is fairly crude. You know, there is constant current load. By the way, there is no way to turn off the load, which is a shame. As I said already when I talked about my own load, this is really something that's very handy. Although he's currently thinking about adding this, maybe with a long press on that button or whatever. You can set what kinds of readouts you want for the main display. A back button here would be nice, so you can really see that this is a this is really work in progress here. Other than that, there isn't much you can set. The display looks really nice, by the way, so no problems there. And I'd say next thing to do is open it up and look at what's inside. So in order to open up the device, I had to undo all the 8 screws here at the corners of the front panel and the back heatsink. Curiously, one screw is sort of longer than the 7 other ones, and I'm not really sure which one it was, but anyway. So once you undid the screws, you can undo the spade connectors here, as well as the flat flex for the front panel, and then you can take out the front panel at the front and pull out the PCB and the heatsink through the back of the unit. and there is also kind of a strange foam thing in there. I have no idea what this is for, maybe just for mechanical support of the PCB, no idea. Anyway, there is that. So this is a bit cumbersome to open, especially because of the flat flex. But anyway, so I opened it up, and let me put like some support here to reduce glare. Okay, there we go. So the first thing I noticed is the wires that go to the front connectors. They're fairly thin. This is a 20 gauge wire, and remember that this unit is supposed to handle 6 amps. Now 6 amps through these wires. They probably did the math and it all checks out. It just appears to be a bit thin. And to me, anyway, that's the first thing I noticed. And then look how the board is nicely segmented into 3 parts here by these lines. That's sort of the USB side here. That's the digital side. That is isolated from the USB side. We're going to have a look at that. And then there's the analog side over there. Anyway, so the USB connector is here, and USB power is taken over to that central slice here by this part here, which provides isolation. Then there is an FTDI chip here, an FT230X, which just bridges between USB and the serial protocol. And then there is isolation over here for the serial lines. Note that it's actually a bit easier to isolate to isolate the serial protocol as opposed to isolating USB. So it makes sense to do it that way and not the other way around. And here is a MOSFET that allows you to actually turn off all of the circuitry. You're going to have a closer look at that later. But apart from that, here this is just powering the digital section of the board. This goes over to the LCD, and there is also the encoder over there. And on the analog side of the board, there is pretty much one half of the system of the SOC. And then the current shunt resistor, as well as, of course, the power MOSFET. And the second thing I noticed here is, have a look at that trace here. That trace is a fairly thick trace. Why is that so? Because it has to carry all the 6 amps that you actually push through the load. So, and there is a similar trace on the back of the board for the return path here. However, look at how this thick trace enters that shunt resistor here, but on the other side of the shunt resistor, there is a fairly thin, that's probably no more than 20 mils, and that is super thin for 6 amps. I'm not sure what they did here. It might be a PCB fuse trace, but usually they look different, sorta, and I just think that this trace is maybe a bit too thin. Anyway, so that's what I noticed. Okay, in order to figure out what's going on in the case where the unit doesn't turn on when I plug it into the USB port, let's have a look at the schematic. This being an open source project, of course, there is a schematic available. It's even a PDF, so you don't have to install any additional PCB software to have a look. However, it's a bit crusty, to be honest. For example, if you look at that designator here, it says FT230X. Of course, that's the FTDI chip. But this is sort of on top of these 2 traces, and there is just no way you can read that, to be honest. In the original, I believe this is blue, but anyway, I couldn't really read it. So it looks a bit crusty. Also, it's not searchable. And then there is, for example, here, that's the DC to DC converter that provides 5-volt isolation. It says RBE, but that doesn't really help. So, you know, so either you don't want to put kind of designators on your schematic and then you don't do it, or you tell me what part that is exactly, but RBE could be anything. In fact, I know what part it is, but still, I mean, you could tell me that's RBE 0505S or whatever. Okay, so in any case, let's focus on that. There is a USB connector here feeding right into the FTDI chip, and then that's the MOSFET I was talking about. And this MOSFET shorts the 5 volts that, or thereabouts, from the USB port to the input of the DC to DC converter, or cuts that connection depending on the voltage on the gate. So there is a fairly 100k a week pull-up resistor here. So if this guy is floating here, then the gate sits at VCC, and this being a P-channel MOSFET, it's off. But as soon as you pull the gate low, it shorts the 5 volts to the input of this X1 converter here. So so that's how that mechanism works. And note that there is also a 100 nanofarad capacitor here, and there's an application note from FTDI telling you how you're supposed to do that, and they did it exactly right. So so that's very nice, because there's one thing with USB. If you think that USB is an easy way to provide 5 volts power to your appliance, I think you're mistaken, unless you have already a bit of experience in doing so, because this stuff is really, USB is horribly complicated. Just how much current you're allowed to pull under what conditions is I have to look it up every single time, because I keep forgetting. It's like, I think 25 microamps if you're in suspension, 100 milliamps if you haven't enumerated the device yet, or if you're connected to a bus powered hub, and 500 milliamps otherwise if you made a successful negotiation with the host. And with USB 3.0 it gets more complicated. With the USB charging spec it gets more complicated. So really, but it looks like they did it right here actually, because that gate of the MOSFET that switches on and off the whole device essentially is connected to 2 pins that are called CBus 0 and CBus 1. So the FTDI chip here does something with these pins, and we're gonna first measure that and then check what exactly these pins are doing in order to understand what is happening. So what I will do is I will hook up a scope, one probe to VCC itself, so that we see when the plug is plugged in, and a second probe to this power enable. This is U1 is just a unpopulated footprint on the board. So there is power enable here that goes to CBus 0, CBus 1, and then through this 1K resistor to the gate. So that's what I want to look at. So I'm going to measure the 5 volts power from USB as well as power N, because power enable is going to tell me what's going on with this MOSFET here. Okay, so I set up the scope. It's already in single shot mode, and the yellow trace is going to be the 5 volts from the USB port, and the red trace is going to be the essentially what you get on the gate of the MOSFET. So the device is currently plugged out, and now I'm going to plug it into my laptop, which is the case where it actually works. So I'm plugging this in. Great. I can observe how the unit powers on, and on the scope I can see these 2 traces here. Now this is the 5 volts from the USB port that I can measure as soon as the plug is plugged in. And here first that a gate here is high, which means that the unit is not powered, the chip and essentially the display and everything. But then after 1, 2, 3, roughly 300 milliseconds, that gate goes low, and that's the point where the unit powers on. So So that's great. That's exactly how it should work, because before the unit can power on and draw a substantial amount of current, it has to negotiate with the host that it is allowed to do so. And that's what's going on in this enumeration and configuration process in these 300 milliseconds before the unit turns on. Anyway, so there is that. So that seems to work nicely. And then if I do exactly the same thing with the other computer where it actually does not work, let's see what we get. So I go into single shot mode again. I have to hold the scope probes here. This is not very easy. And then I plug in the USB cable into my computer, and I get this. Great. So in contrast to what we saw before, this time that gate does not go low, and in fact the unit is turned off. And if I were to measure the voltage on the gate, even now it would still be high. So that is what is going on. Now why is that? I think this is because on the computer where it's not working, I have not installed the FTDI drivers because I've never had any use for them. So probably Windows does not go through the whole enumeration process, and because this pin is only supposed to go low after the enumeration has, or the configuration has completed. This is just not happening, and therefore it remains high. So in a way, this is exactly how it should happen, although it's a bit frustrating because the first thing I did when I got the unit is I plugged it in into this computer and it didn't power up, so I was very confused, and only maybe 20 minutes later I actually it occurred to me that I might give another computer a try, and that happened to be my Linux computer where an FTDI kernel module is pre-installed anyway, so so that works just fine. Okay, I get the feeling that I maybe should clarify a few things on this voltage control thing that we just looked at. Now, if you ever worked with an FTDI chip, you probably know that in addition to like the TX and the RX pins, there is a bunch of C-bus pins, and essentially you can set by software what these pins are doing. Now that could be LED control for, you know, having LEDs that blink when you transmit and receive stuff. But there is a lot of different functions, and what you can do is you can set the pin, for example, to go low when the enumeration, the USB enumeration has happened, which is what they are doing with one of these two C-bus pins here. Note that they're tied together here, which means that you know, you plug it in, it goes through enumeration, and when that is done, the pin goes low, which is exactly what we saw on the scope. The other one is set to go low when you hook up a USB charger, which is really nice because, you know, they thought about something here. Let's say you do not want to use the reload to do any communication with a PC, but you still have to power it somehow. So you use a USB charger and plug it in there. However, using a USB charger will never lead to successful enumeration because there is just no USB host that allows you to enumerate your device. So instead, there is a charger detect feature that goes low when a charger is detected. I'm not really sure how this is done inside the chip. Probably just if there is no USB frames coming in, it does that. But anyway, I don't know how this is solved. I'm not sure whether you can tie these two together, although they probably, you know, looked at that and decided that you could do that. So in either case, this power enable here goes low and turns on the whole thing. Okay, let's wrap it up. In the meantime, I showed the footage that I recorded to Nick Johnson. I had the chance to chat with him, and he had a bunch of comments actually. And the most important one I want to show right now, because he told me that after flashing the latest firmware, which is recommended, I should first perform a factory reset and then calibrate the unit. And this turns out to be a bug of some sort. In any case, I did that, and look, now if I set 20 milliamps here, it's actually pulling pretty much 20 milliamps, and I assure you that on the power supply it's reading somewhere about 22 milliamps or so. So that is working exactly the way it should. That's 40 milliamps, 60 milliamps, 80 milliamps. That's the current readout here. No problems whatsoever, and even if I pull more, no problem. 340 milliamps. So that's working just fine. No problems there. It would have been nice if he had written somewhere, maybe in the manual, that you actually have to perform this factory reset. On the other hand, it turns out that the manual actually says or tells you how to disassemble and assemble the unit, even though I complained about that. So that tells you how coarsely I read the manual anyway, so no problems there whatsoever. Then on the FTDI driver, I actually went ahead and installed the FTDI driver on my Windows machine, and then you plug it in, it works just fine. And actually, in order to be compliant with the USB standard, that is how you have to do it. There is no way around it. You can make a minor software change in the FTDI chip configuration to disable that mechanism, but Nick Johnson, we talked about this, and he said that he deliberately chose to be compliant with the standard, which, as I said, I believe is the proper decision. Anyway, what I haven't shown is the computer interface, because this is a standard serial USB interface, so you can read out your measurements, change the set points. Actually, you can set it in 1 milliamp steps, in contrast to what I can do with this knob here. But that I tried that, and it works just fine. Lastly, on the cable and PCB stuff, in fact, he told me that he checked the math for the cables and they're rated properly, and I didn't check, but I trust him to do his engineering homework, so I don't think there is a problem with that. And also that PCB trace, turns out that was actually a PCB mistake, but it doesn't have any serious consequences, because essentially that thin PCB trace does two things. The first one is it adds a bit of resistance, so there is a fairly low resistance shunt in there, and that thin trace is in series with that shunt, so in fact the resistance is a bit larger. But of course you can calibrate that out. It's just that if this turns out to be to change with temperature, you're in trouble. But he said that this has no major consequences. The second problem is that, of course, because the resistance is higher, there is larger voltage drop and also more power dissipation. But he checked that as well, and there is no problem with that. So that's great. Okay, so all that said, I'm very happy that he could clarify a few things here. I think with all that said, this unit is even greater. You really should consider getting one of these in case this is something you need. It's very handy to test various things. You can also go for the non-computer enabled version. It's considerably cheaper, just as nice. I really like the stuff he's doing up there, and I'm happy that I could review this unit here. That said, thank you very much for watching. If you have any comments, anything to say, please do so below, and see you next time.